Hello, I'm very excited to release the QGIS plugin for SamGeo, segment anything model for geospatial. How about Meta's SAM3 model release about 2 to 3 weeks ago, and it's going to make your life so much easier. So now you can use the plugin in QGIS to segment imagery without having to write any lines of code. So in this video, I'm going to show you how to set it up and how to walk through different types of prompts you can use to segment geospatial data. So let's get started. First, you need to go to the GitHub repository to get the plugin. I'm working to publish this plugin in the official QGIS plugin repository. It might take a couple of days or weeks, but for now, if you really want to try it out, you can go to the link in the description below to go to the GitHub repository, and then you can follow the instructions to install the environment and then install the plugin. I'm going to briefly go through the steps here. First, you need to install QGIS and also segment geospatial. If you already have QGIS installed in your desktop, I highly recommend that you create a new Conda environment, because the SamGeo package has a lot of dependencies, and especially some of the GPU dependencies. It might not be available through your desktop installation, and it's recommended to create a new Conda environment. Then you can install QGIS. You don't need to go to the QGIS website to download anything. You can install all the dependencies just using Conda. So create a new Conda environment, activate the environment, then you can install QGIS and also segment geospatial. Once you have that, I also recommend that you update using pip, because some of the dependencies are not available on Conda yet, and you might need to install pip to update to the latest version. So just follow these two steps. Once you are done, then you can clone this GitHub repository, then just install using either the Python script or using the shell script. So basically what you need to do is to clone this one to your computer, or you can download this one as a zip file. Either one is fine. After that, you can go to somewhere on your computer. For me, you can clone into the downloads directory or somewhere, for example, here on your documents directory. So just open your terminal, then you can just git clone and then paste. You will be able to clone this one to your user directory here, and then you can double click inside. You'll be able to find this script here, the Python script or the install the Python script. So for me, I can just open my terminal here from this directory, and then Conda activate Geo. Okay, so this is basically the Conda environment that we have QGIS install and also the plugin. Then all you need to do is just Python install the plugin.py. After that, you should be done. So like I said, in the future, I'm going to you will be able to install it directly from the QGIS plugin repository. For now, just use this way. And it's going to show you all the blah blah has been installed to the user directory. Then you can start QGIS. So from here, I can just Conda run QGIS. So don't use the QGIS come with your desktop installation. You want to use the Conda version. So, and then it's going to start QGIS. After that, you can go to the plugins menu. So here, then click in manage and install the plugin repository. From here, make sure you check the box SamGeo here. If this is unchecked, check the box. If this is the first time, then click close. You should be good to go. And there are two ways you can use the same activate the SamGeo plugin. Maybe let me create a new canvas. And on the left side here, you will be able to see this icon, the SamGeo. It's a little bit too small. If you don't see this one, you can go to raster and then SamGeo segmentation. And then on the right, it should pop up the panel here with multiple tabs: model, text, interactive, batch, and also output. I'm going to show you step by step how to utilize this one. And first, you need to have some data you want to play with. If you don't have any data, you can go to the plugin repository here, and then go to step number 2 here, set an image. And then you can click the link here to download a sample imagery to your computer. So this is a set an imagery covering UC Berkeley. So you can click this one and then save. It should download this one to your computer. And after that, you can just drag and drop the file to here. So I'm going to drag the file, and that's it. So now we have this imagery that we can play with. Next, I'm going to show you how to utilize this. Let me move this one maybe a little bit bigger. And first, you need to load the model. So upper right corner here, you'll be able to see we have different versions of the SamGeo model. I'm going to use same version 3. It's the base one. It has a lot of capability. And let me move my camera to the left side here. All right, so once you select the SamGeo 3 model, you will notice here if you have used the SamGeo Python package, there are two backends. The first one is the meta, the second one is the transformer. You can just use the default one. You don't have to change anything. And then use the device auto. So in order to run this segmentation, you do need to have some kind of GPU. Otherwise, it might be a little bit slow. So you can just let the auto. If you have the GPU, you will use the GPU. If not, you will use the CPU. Also enable the interactive mode. Later, if you want to select points interactively on the map, you can do that as well. So what you need to do here, just the first step, click load the model. It's going to take maybe 10-20 seconds, depends on your computer hardware, and it's going to load everything into the GPU. So if you want to check it, I can open my terminal here, then just type mvtop. This is basically utility. They're going to show you the status of the GPU, and you do notice here I have two GPU, each one 16 gigabyte, and after that you should be able to see it's loaded the model into the GPU, and then it's increasing. Also here you see 4.6 gigabyte, the other one is 2.7 something gigabyte. And so this is basically where the GPU, the same 3 model is being loaded to the GPU. The size is around 3.5 gigabyte for the model itself, and there are some other overhead, and it's roughly 4 gigabyte here. Once the model is loaded, the next step is to set the imagery. So you can either open the file on your computer, or you can load the image layer. And on the right here, you can click this refresh button to refresh. Then you will see this one in the drop-down list. You can have multiple layers same time here if you need it. And then all you need to do is just click this button, set image from layer. You will be able to see here image. And then if you see the green text here, that means it has been, the image has been set. So basically creating the image embedding based on the input. And that's all. So now we have the model loaded, we have the image specified. The next step is to start doing the segmentation. So the first one we're going to try here is the text prompt segmentation. And you can pretty much enter any text prompt. Then we can use SAM3 to automatically segment it for you. For example, here I can just type building, okay, and then you can adjust the parameters. So if there's some, like you want to remove some small objects, you can set the medium size here, for example, 100 pixels. So depends on the object that you are trying to segment, you can remove this kind of smaller false positive objects. For the maximum size, if you know that, for example, a building is not going to exceed like 1 million pixels, you can do that as well. For me, I don't want to specify it, because just use the default one. Then click this button here, segment by text. So just click the button, and then you see less than 1 second. Now you see this one, the text here, file 47 objects, and go to the output tab to save. So then we can go to the output tab. From here, you'll be able to select what kind of output you want to see. So by default, it's going to be the raster GeoTIFF output. And you can also specify the output. But when you are testing, you don't really need to. You can just click the save mask. Also at the bottom here, you will see like text prompt segmentation results, prompt building, object file 47. So let's try this one, save mask, okay? And then just click the button. Take a look. Now we have the segmentation automatically showed up on the imagery here. Super nice, and it's pretty clean. You can see it from here. I'm going to basically showing you here. Double click, and then we can show the symbology, not symbology, transparency, and then change to 0. Also, I'm going to have the transparency maybe 50%, something like that. And take a look, 50% might be too transparent. Let me make it a little bit larger, 70%. So look at this. Now we have this segmentation showing up here automatically on the map, and it looks pretty nice, and it only takes you like just seconds. So let me change this here. Oops. Let me see here. And if you find the result looks good, you can right click from here on the left side. Let's show my screen here. Oops. So you can right click somewhere here, right click, then you can save this one, export the data just like you normally do in QGIS. So this is how you can do it easily by doing the image segmentation just using a text prompt segmentation. Also, you can get the result as a vector format. On the right here, you can select vector. It can be a geo package or some other data format, whatever you want. I can select, for example, vector geo package, then save mask. Now you take a look. We have the buildings as vector data set. So for here, let me change this one just to transparent, and look at this. Super fast, super quick. So this is just using the text prompt. Of course, you can use some other ways to, for example, you can try, let's say, trees. Okay, so I can segment using tree segment, oops, or 3G. There's a typo here. Segment by tree. Okay, found 48 object. Then we can just save mask. Let's take a look. These are all pretty tiny. And let me change this one out. So you can see there are a lot of like missing detections. You can go to the model. So here it is where you can make the adjustment. If it is like the confidence level is too high, you can change to 0.2 or something like that, and then reload the model. Then you are going to get more detections. Because it's going to take time, I'm not going to show you, but just showing you, you can customize some of those things if you want to. So this is using the text prompt segmentation. Let me remove the results quickly here. Remove it there. So next, I'm going to show you using the interactive segmentation. So go to the second tab, interactive. From here, you can create foreground and background points. That means if you're trying to detect something and you want to, for example, select individual objects, then you can do it like this way. So I'm going to click this button, add foreground points. So once you click this button, it's going to be activated. Then you can come back to the imagery here. Then you can select any object. For example, I want to detect this one. You can click one point on the map. This is going to basically just the positive points. And make sure that you don't click, if you really want to detect, don't try to click points outside the object, because right now it's going to treat everything as a single object. So this is only good for individual objects. And for example, I can have 2 points. Then I can just click this one, segment by points. Okay, it's going to say, okay, find one object, go to the output. So I'm going to go to the output tab and then save mask. And take a look. Now you see we have this segmented, although there are some like still missing one here. If you want, you can add more points. So I'm going to go back to here, interactive again, add ground points. So for example, I can add something like this. Then it should detect all of them. So segment by points, one object, and then I can go to save mask again. Take a look. So now I have this entire building have been segmented. But you might notice here, there's also something inside. If this inside something you don't want, then you want to add a background points. So I'm going to go to the interactive again, add background points. That means there's something I don't want. Then I can just maybe have some points in here. That means I don't want to detect all the trees. And let's try again. So I'm going to go back to here, segment by points, and then output, save mask. Oops. Interesting. So maybe this, but it should not include this one inside here. How about this? Let me remove it. And make sure the interactive, I have the points, I have the output. All right, so that might be probably a bug. Let me look at the raster mask. Okay, so there's a bug. It's not supposed to include the background points. Anyway, I will look into the source code. So the next one I'm going to show you. Let me remove all this. Okay, even more powerful one is the box prompt segmentation. In the interactive here, let me clear all the points so that it's not showing up here on the map. And what you can do here is to go to the second one, draw a box, right? And this is the power of using the same tree, because it allows you to find all the similar objects within the same image. So in that way, I don't have to draw so many bounding boxes. I just need one. Click this button and then move your mouse to the map. For here, I can just maybe click here and I can draw a rectangle somewhere here. All right. After that, just click the button here, segment by box. Okay, click. And it's going to show you, okay, found 43 objects. Go to the output tab and then save mask. See how cool is this? I have segmented all the objects. So the result is very similar to the text prompt segmentation, like using the building. But now I can ask it to create any similar object that I want. So these are all the buildings here, right? It doesn't necessarily have to be buildings. I can try to find something else. So let me go back to the tab here. I'm going to click the box. Then I can draw something else. So for example, I can draw the box and then come here. I can select a box of maybe trees or something like that. See if it works. So I'm going to select this one and then go back to here, segment by box. Only found one object. Interesting. And then segment the mask. Okay, this is not a good example. Let me try again. Interactive. Clear the bounding box. And let me remove this data layer. How about this? Let's try a different draw a box. How about this one? And then, oh, maybe also you need to space it. If you find the result is not very good, go to the confidence level here, change it to a smaller number. Sometimes we get better results. So I've already, oh, I need to redraw the box maybe here. Okay. And then segment by box. Now you see found 27 objects. Okay. So definitely it depends. This is kind of varies. If your object is very obvious, it's going to be able to find many objects, but sometimes it might little bit ambiguous, then the result might not be very good. So here we have found 27 objects, then go to the output, save mask. Okay, so this is what we get. We can turn the layer, or maybe just show the vector data. It'll be gonna easier. Save mask. Now we have this vector data set. I can turn this one off. Then I can double click. From here, simple, just the outline color. Yeah, it does detect some of the trees. Based on this example, like I said, there are some other stuff in here. So you can try to basically use more bounding boxes to find all the one that you want. So it works very well for buildings, not so much for trees. Like I said, you need to adjust the parameters. So this is the interactive mode. And then last one I'm going to show you is the batch mode. So earlier, when we select a point to detect the buildings, when you have multiple points, the result is not very good because it's treating all the points belonging to the same objects. But sometimes this might not be what you want. Let me go back to here, clear the box. So if you want to detect individual buildings, like for example, for each point is one building, then you will need to use the batch mode. In here, just click this add points to the map. Then you can come to somewhere. Here, I can click this one, 1, 2, 3, 4, 5, or something like that. On the right here, you're going to show you how many points have been collected. In total, that's 5 points. And this is what we need. At the bottom here, just run this one, run batch segmentation. So it's going to basically segment all the objects that intersecting with all the points. So let's run this one, and the result, okay, found 5 objects. Then we can go to the output here, click save mask, all right? And take a look, now we have all the points. For the 5 points, each one is being detected. Of course, it's not going to be, it's going to guess. Sometimes it might not be exactly what you want because it's treating each one as individual one. It might be just detecting the, what's that called? The rooftop. So you do need to be careful about what you want or what kind of a points you use. And you can do that either interactively or you can also input a file. So let me show you here. I'm going to clear the output. And then from here, you can select a file. Let me show you. I have a file here on the Hugging Face. So let me go to my Hugging Face. I can show you how to download the file. So I already have some of the points that detected the centroid for each one. So I'm going to go to here and then there should be one called WA. Let's see here. Oh, it's on the GitHub repository. So let me go to the same repository here, OpenGeo OS, and then you can use bounding boxes. So for now, I'm just going to show you the point. So go to dataset, and then on the right here, releases. The link is also in the video description. So I'm going to show the link so you can use that. I think it's under here. Okay. WA buildings Centroid. So I'm going to download this one to my computer. Okay, save to the download directory. Then I can load this file directly into QGIS. So I'm gonna load this file here, and you will notice each point, right? Oops. Oh, this is a different one. Anyway, let me show you. Let me remove the imagery. I'm going to add also a different imagery here using this one. WA Washington buildings. So I'm going to use two different imagery because they central is for this one. Load this one here and then load the central. And take a look. Now I should have this building imagery with central for each building. Sometimes you might have multiple in here. And this is something that you might already have from other data sources. So if you want to extract all the buildings using this kind of central, then we can use the base mode. But because we changed the imagery, so now we need to set the data. So I need to go to here and then select this Washington building image, set image from layer. Once it's done, then go to the base mode here. At the bottom, you can either load from a file or you can select from a layer. So just click the refresh button and then select this data layer. Once it's done, then click this run base segmentation. So I'm going to run this one and hopefully it works. You're going to run through basically each one is individual. Okay, it's done. Found 269 objects, and then we can go to the output tab. Then from here, I can just save mask. Oops. Did not match the along. Interesting. Something is wrong. Did not match the size. It's probably because save mask. Okay, because probably I changed the images, so this might be something has been, I think because the model, so we might try to reload the model just in case. I think earlier when we do the segmentation, so some of the case might still be in the model. So let's try this one again, select the layer, then I can go to the base mode here and use this one, run the base segmentation. Oops. Okay, Conda out of memory. Okay, that's not very good. Let me close everything and let me double check the Conda here. Okay, it's revert back to the normal one. And let me try again. I'm pretty sure it should work. Okay, let me open this one and then let me drag the file again. Then we can reload it. I do want to show you because it's a very useful feature. So, and then from here, I can load the model again. Take a couple seconds. Then we can set the data layer. Okay, model is loaded. Then select the imagery and go to the base mode here. Select this data layer and then run the base segmentation. You can also adjust the size. So if you want to specify the minimum and the maximum size, you can do that here if you want to. Then just run the base segmentation. Okay, 269 objects, and then go to the output. Now it's correct. So here it's going to show you, okay, 269 objects, save mask. Good. So now we have this result loaded correctly. Also, you can save as a vector data set if you want to. It's going to select the geo packet and then save mask. Now we have all this. There are some kind of artifacts that we need to do some cleanup or use the SamGeo package to do rectangularization. For now, I haven't integrated that one yet. Just going to show you this is a preliminary version. It's going to get so much better. But you can try it with your own data and then feel free to leave comments down below, or you can go to the GitHub repository to leave comments if you run into any issues. And so this is going to make remote sensing image segmentation so much more accessible and easier. Now, you don't need to have deep knowledge about deep learning or segmentation. You can just use QGIS and then just couple click low imagery, then you should be able to do the segmentation. And I hope you find it useful. I will see you in the next one. Take care. Bye-bye.